hello, this is Mr. Leapforth along with,
Joe.
and we're going to do the 2012 AB Calculus question 2 from the AP exam. And we had already graphed it up. My assumption is that you have the problem right in front of you and that you're feeling free to stop, pause, go back, or whatever you need to do during it. So the first part here just asks you to find the area, and so that's what we're going to start with here. So I drew the graph, and sorry about the creaking here. I'm trying to get it in a good position, but we have the graph. The red graph is the natural log of x, and the blue graph is 5 minus x, the line. And these parts, if you look at the problem, these parts weren't on there. So we're just looking at that green region R, and we want to find the area. So Joe, you and I were talking earlier. We want to find the place where these two graphs do what?
Intersect.
Yeah, where they cross or intersect. So so we graphed it already, and so this calculator allows us to go to second calc intersect. Again, this is on the graphing calculator portion of the test. First curve, yep. Second curve, yep. And then you have it tell you where it's going to be. And so I got like 3.693441. That's crazy, right? But that's an answer that we want to try to keep. And then the 1.30 okay, so we got all that. So basically it was like 3.69344 and 1.30656. That's where they intersect. That's this point right there. And so that's going to be an important point. What you probably want to do is, not probably, I mean this is what you need to do next. You type in x, and then what you want to do is store that in alpha A, because we don't want to round that. We want to keep that nice solid answer in A. Not only can you store that intersection point in your calculator, but as we start to find the area, starting at 1, basically we can go all the way to A. Alright, A is 3.6 or whatever, but you can just call it A. You're going to get points on the AP exam for writing the integral down. So that's the natural log of x to start. And then you want to add that to the area from A to 5 of the other graph, which is 5 minus x. And so I'm actually just using my calculator for that. So you got on the AP exam 1 point for the integrand, 1 point for the limits of integration, and then 1 point for the answer. What is the answer to this, Joe?
2.986 or 2.985.
And so it seems like the 2.985 is truncated, just cut off to 3 decimal places, and the 2.986 is rounded, but maybe whoa, that was not supposed to happen. Ha, tried to grab my calculator. You guys probably got a little seasick there. Sorry about that. Okay, so, alright, we have them typed in. So basically, we want to type this into our calculator. So you go math 9, which is your function integrate. We want to natural log, which was in y1. So you go variables, y variables, function y1. With respect to x, we want to start at 1 and end at what you stored in alpha A. And so that's the first piece. And we want to add that to math 9. Let's try that one more time. Math 9, and then variables, y variables, function 2 this time, y2, with respect to x. Put a comma in between. With respect to x, you're going to go from alpha A and comma alpha A. Yeah, I can pretend like I'm doing this on purpose, but either I'm not behaving or my calculator's not behaving. Which one do you think, Joe?
Probably calculator.
Everybody's like, what is she doing? Alpha A. Did it work? Good. Comma. That never happens to you, does it, Joe?
Nope.
Okay, so there's our answer. So that's what we got, the 2.985. If you cut it off, that's a good answer for you, 2.986 if you want to round up. I'm going to remember the 2.9858. Can you remember 04105? Can you remember that?
Sure.
What was yours?
04105.
Okay, let's just check that just to make sure so they don't think we're crazy. 2.9858044105. That's also a good answer. Most people want to truncate it around to 3 decimal places, though. Okay, so that answer is perfectly fine as well, so you're allowed to do that. Okay, so we're gonna do B. I'm actually gonna, you'll see me erase this here, but you can always go back in the video to see it, but we'll erase this. The second part asks you in part B to find the volume. And let's clean up a little bit more. So the volume, what we want to find is it is a base. This region R is a base of a solid, and what we have is squares coming up off the graph. So this is always crazy to find that. But basically, you want to add them all up from 1 to A, and you want the area of a square. The area of a square is base times height, but in a square, the base and height are the same.
Yep.
And so you just take the base and square it. So this base here, what graph are we using? What's the red graph? ln x, right? Natural log x. So that's the first piece, and we want to do that with respect to x. And then we want to add that to, we're going to go from A, and we're going to end at,
5.
and that graph was the blue graph, which was what?
Which was 5 minus x.
And again, we want to have squares coming up off that, so it's like you have the base with the square coming up. So all I ever do is just look to see what the base is, and then based on the shape, you can figure it out. And for B, it's just write but do not evaluate. So actually we are done. You know, you want to be careful with all your evaluation. On the paper, you can't just keep saying A. So on your paper, you needed to say A with all the decimal places, 3.69344. You needed to tell us earlier on the page, so that would work. Okay? And then for C, C is a little bit challenging here. It wants the horizontal line y equals k. That cuts the area in half. So you have like this, and basically you want to cut the area in half. Not sure exactly where that happens. So, you know, there's a couple different ways to do this one. So since you got y equals k, I just wanted to make sure I was answering the right question. Since it's y equals k, that's in terms of y. It might be helpful to change the equations around. So instead of having the natural log for the one graph, instead of having natural log, you can go e to the y, all right? And then instead, whoops, let me make that a clear e. Instead of 5 minus x, you can make it 5 minus y. Now, just so that didn't totally look like a magic trick, y equals natural log of x means that e to the y power equals x. That's the rewrite. And y equals 5 minus x, you know, basically you add x, you subtract y, and you get x equals 5 minus y. So the y's are the ones we want. And basically what we want is to take the area and divide it by 2. So we want the area from 0 in terms of, that's like your x-axis, to some point k. I'm not sure what that is. The function on the right is 5 minus y, and the one on the left is, we were calling it natural log, but we changed it to e to the y power, right? And we're differentiating with respect to y. So that's going to be the area of the whole graph, the whole region, but we only want half that. We want to figure out where's the place where it's divided in half. And so if we calculate that all out, I'm going to actually pause the video and type it in. Alright, so this happens all the time in an AP test. You get your rhythm going, and then you read through the problem. If you start to go to the calculator and you realize you messed up a little bit. So we got to determine, I'm looking at the clock, it's 9 minutes in, so I'm still okay. But this was some area that we want. We want that one here on the left, we want that to be 1/2 of the whole area. I forgot in A we had found out the area of the whole thing was 2.986. So now we have a better framework. We want this area from 0 to k, we want that to equal half the area. And so we need to determine where k is.
But it could also be half of 2.9852.
Alright, cool. And then I was freaking out a little bit too because I thought we had to solve it, but you actually don't have to solve it, which is good. So we got our integrand, limits of integration, equation. Spent a little bit of time based on that 1/2 thing, but I think we have it set up well now. And I guess that's it for number 2.